Welcome to Session 5. This one is a signature SAT question type, and once you see the pattern, you'll spot it from across the room. It sounds like this. For what value of k does this system have exactly one solution? Or, for which values of k do these graphs never meet? There's a letter in the equations that isn't x or y. We call that a parameter. And the question is asking you to control it. Here's the good news. You already have everything you need. This entire session is one idea, the discriminant, pointed in a new direction. First, what is a parameter actually doing? Look at y equals 2x plus k. The x and the y are the variables. They're the coordinates of points on the graph. But k is different. K is a dial. Fix k at some number, and you get one specific line. Change k, and you slide that line up or down. The slope never changes, so every choice of k gives you a parallel copy of the same line. Now picture that family of parallel lines sweeping across a fixed parabola. High up, the line cuts through the curve at 2 points. Slide it down, and those two crossings drift toward each other. Keep going, and they merge into a single touch. Go further, and the line drops away entirely, no contact. That sweep is the whole question. The SAT is just asking you where in the sweep you are. So, let's name that middle moment. When the line touches the parabola at exactly 1 point, we say the line is tangent to the curve. And here's the translation you must have automatic. Exactly one solution means tangent, means the discriminant equals 0. Those three phrases are the same fact in 3 languages: the algebra language, the geometry language, and the SAT's language. Why is it d equals 0? Because when you set the two expressions equal, you get a quadratic, and one solution means a repeated root. And a repeated root means the thing under the radical vanished. So the instant you read exactly one solution, your hand should already be writing d equals 0. Don't solve for x, don't find the point. Set the discriminant to 0 and solve for the parameter. Let's do it. Y equals x squared, and y equals 2x plus k. Find k so the system has exactly one solution. Set them equal. X squared equals 2x plus k. Move everything to one side. X squared minus 2x minus k equals 0. Now read off the coefficients carefully. A is 1, B is negative 2, and C, watch the sign, C is negative k, because the term is minus k. Now the discriminant. B squared minus 4ac is negative 2 squared, minus 4 times 1 times negative k. That's 4 plus 4k. Notice the sign flip. Minus 4 times negative k becomes plus 4k. Set it to 0. 4 plus 4k equals 0, so k equals negative 1. And that's the answer. The line y equals 2x minus 1 is tangent to the parabola y equals x squared. If you want the touch point, the repeated root is x equals negative b over 2a, which is 1. Let's do the general version, because your practice set is built on exactly this shape. Take y equals x squared plus k, and y equals 2hx plus c. I'm writing the slope as 2h on purpose. It makes the arithmetic come out clean, and the SAT tends to use even slopes here for the same reason. Set them equal. X squared plus k equals 2hx plus c. Rearrange. X squared minus 2hx plus the quantity k minus c equals 0. The discriminant is 4h squared minus 4 times the quantity k minus c. Set that to 0 and divide by 4. H squared equals k minus c, so k equals c plus h squared. That's your tangency formula for this family. Take half the slope, square it, add the line's intercept. But please, understand the derivation rather than memorizing the result. If the problem shifts even slightly, the derivation survives and the memorized formula doesn't. Now, let's get the full picture, not just the tangent case. We found that the discriminant is 4h squared minus 4 times k minus c. Tangency was where it equals 0, at k equals c plus h squared. Call that the boundary. Now think about which way the inequality runs. The discriminant has a minus k in it, so as k gets bigger, d gets smaller. That means when k is below the boundary, d is positive, and you get 2 intersections. When k sits exactly on the boundary, d is 0. Tangent, 1 intersection. And when k is above the boundary, d is negative, and there are no real intersections at all. Below is 2, on is 1, above is none. And that matches the picture perfectly. Raising k lifts the parabola away from the line until they lose contact. Here's a twist the SAT loves, and it catches people. Sometimes the parameter isn't the intercept, it's the slope. Take y equals x squared plus 1, and y equals mx minus 3. Find m for tangency. Same procedure, no panic. Set them equal. X squared plus 1 equals mx minus 3. Rearrange. X squared minus mx plus 4 equals 0. The discriminant is negative m squared minus 4 times 1 times 4. That's m squared minus 16. Set it to 0. M squared equals 16, so m equals plus or minus 4. 2 answers. And that is not a mistake. Geometrically, it's obvious once you see it. The parabola has one tangent line of a given steepness on its left side, and a mirror image one on its right. So when a parameter question gives you a squared parameter, expect 2 values, and check whether the answer choices are offering you both. Let's do one from your practice set. For what value of k are y equals x squared plus k, and y equals 2x minus 3, tangent? Set them equal. X squared plus k equals 2x minus 3. Bring everything left. X squared minus 2x plus the quantity k plus 3 equals 0. Now the discriminant. Negative 2 squared is 4, minus 4 times 1 times k plus 3. So d is 4 minus 4k minus 12, which simplifies to negative 4k minus 8. Tangent means d equals 0, so negative 4k equals 8, and k equals negative 2. The answer is A. Quick check with our formula. K equals c plus h squared. Here c is negative 3, and h is 1. So k is negative 3 plus 1, which is negative 2. It matches. 2 independent roads to the same answer. That's how you know you're right. Before we recap, the trap. On a parameter question, students very often solve for x. They'll do the algebra beautifully, find that x equals 1, and confidently circle 1. But the question never asked where the graphs touch. It asked for k. The x value is scaffolding. It's the ladder you climbed, not the thing on the shelf. So here's the habit. Before you write anything, underline what the question wants. If it says find k, then your final line must start with k equals. And a bonus tip, if the answer choices are inequalities like k less than 5, then it's a range question, not a tangency question. The choices themselves are telling you whether to set d equal to 0 or to make it positive or negative. Let's recap. A parameter is a dial that slides the graph without changing its shape. Exactly one solution, tangent, and d equals 0 are 3 names for one event. The method never changes. Set the expressions equal, collect into a quadratic, compute the discriminant, and then set it to 0 or positive or negative, depending on what was asked. For the family y equals x squared plus k against y equals 2hx plus c, the boundary is k equals c plus h squared. Below it 2 intersections, on it 1, above it none. If the parameter shows up squared, expect 2 valid answers. And always finish by answering for the parameter. Terrific work on session 5. Parameter questions used to be the ones students skipped. Now they should be the ones you look forward to, because they're mechanical once you see the discriminant behind them. In session 6, we take all of this into the real world: projectiles, areas, revenue, and cost. Same algebra, but now we'll have to decide which answers actually make sense.